Okay, then let's continue with the next presentation, and we go to a topic that was already mentioned in a couple of other presentations, and that's the end of life. So we start about talking about recycling, and I'm really happy to have with us Janett, who's the head of research and development at Solar Materials. A company that actually won at Solar Power Europe, where I was also involved in 2 awards. One as a startup award, because the audience in the event found that the project, that the company had a really interesting project, and they are actually also the current gold winner of the European Solar Sustainability Award of Solar Power Europe. So I'm very excited to hear what about the progress at Solar Materials. Janett, the floor is yours.
So, hi, Michael. Thank you for that very nice introduction. So, I share my slides. 1 minute, 1 second more. So, I think you should see my desktop and slides. Everything fine?
Yep.
Okay. Just 1 second. Okay, then I start with the presentation. So, welcome everybody. So my name is Janett Schmelzer. I'm head of research and development at Solar Materials. And today I'd like to take you on a little journey into our topic of the PV module recycling, a very crucial topic for us as the first generation of the solar panels reach its end of life. So what we do is, yes, we transform solar waste into strategic raw materials. So we do this by means of scalable and profitable technologies for recovering silver and silicon. So something about us, Solar Material was founded in 2021 in Magdeburg in Germany. We currently operate Europe's more or less most advanced recycling facility for crystalline silicon solar modules, with a recycling capacity of around about 7,000 tons per year. And in our team, we have more than 50 employees up to now, industrial experts as well as scientific staff. So, and all together we try to develop the cutting edge recycling process. And yes, we have a big mission, and our goal is to close the loop for the solar industry, from waste back to high quality raw materials. So typically the modules we recycle came from various sources. So as you see, a little bit of something very colorful, but some of them are damaged by heavy weather events such as hail or storms. Others reach their technical end of life due to degradation, maybe, or they are replaced sometimes during repowering projects. So this is what we have to recycle here. And we have also modules that fail, for example, quality checks during production. But each type of the modules represents a valuable opportunity to recover critical materials and reduce environmental impacts. So we try to do our best, and the modules typically arrive stacked on pallets, which is directly a problem because the transport capacity is a big problem. So due to the frame and the glass, the modules are very heavy and waste a lot of space during transportation. So this is the first point we have to focus on, but not in this talk today, but let's keep this in mind. As you see, what happens within the next days, the number of end-of-life PV modules is growing rapidly. You see it here in the scheme. By 2030, the annual solar waste volumes will increase 20-fold compared to today, which is really a lot. So in this waste, represents both a challenge and yes, a significant economic opportunity. So as a contained raw materials, especially silver and silicon, have a combined market value in the billion of euros. So point is efficient recycling will be a big step into securing these strategic resources. So yes, as a recycler, we can say we are always 10 to 15 years behind the production. So the circle shows where we are now. So, and you see a big wave of end-of-life panels is on its way to us, and we need to recycle them. But first, yes, let's look into the legislative framework, which is also a key driver for the future of the PV recycling. So in Europe, yes, PV modules have been included under the WEEE directive since 2012, which means that the solar panel producers are legally responsible for the collection, as well for the treatment and for the recycling of their end-of-life products, a concept which is known as extended producer responsibility. In Europe, we also have the European Green Deal and the Circular Economy Action, which go even further. They require to reduce resources, dependencies, and strengthen local recycling capabilities. And these laws create a strong incentive for big innovation we need. So by contrast, in the United States, there's no federal regulation for PV recycling up to now. So some states like California have begun to act, but overall, so the system remains more or less fragmented. In Asia, it is coming up. So countries such as China and Japan are busy to expand recycling capacities. Anyway, so all we have is one thing in common. So we have a big volume to recycle versus a high purity material recovery. So yes, establishing a sufficient recycling structure for the solar modules is really a global challenge. So Europe, in particular, has now the chance to start over a little bit by developing sustainable solutions. Yes, recycling allows us to save valuable resources, especially in case of the PV modules, the silver and the silicon. So we can reduce dependency on imports of rare materials and strengthen the circular economy. But when we look inside a solar module, most of the weight, around about 65%, comes from the glass and the aluminum, which is relatively easy to recycle. But when we analyze the economic values, it is clear that silver becomes really a key driver. Although, yes, it represents less than 0.5% of the total weight, it contributes with over 45% of the module's material value. So it is really worth to recover it. Another thing is the silicon, which also plays an important role. But yeah, for the silicon, we have to state that the worth strongly depends on its purity. So the question is, how can we increase the purity of the recovered silicon? This is one question we ask us. And what we have next to silver, silicon, glass, and aluminum is a lot of plastic. So we have the recovered EVA foil as well as the back sheets. But yes, those parts of the PV module are more or less, yeah, worthless at the moment. So, but we have 10% of plastic within every module. So the question here is, what can we do with the recovered plastics? So these are three questions we really ask ourselves. So how can we efficiently recover silver, which is very important because it's, yeah, very profitable to recover it. how can we increase the purity of the recovered silicon, and what can we do with the recovered plastics? So yes, silver is mostly found in the solar cells and in the bus bars. So, however, the problem is it's not easy to access this material because the silver is encapsulated between the layers of the EVA film. Also, this type of plastic we need to remove first. So how can we do this? So there are typically three ways to do that: a thermal way, a chemical way, and the mechanical way. Yes, and there are different approaches to do that. And as you see, each, each method has its own advantage and limitations in terms of efficiency, costs, as well as environmental impacts. And what you can see that none of the approaches is able to tick all the points. So some green ticks here, but some red crosses everywhere. So we try to solve that problem and we optimized the processes to make silver recovery pretty economically viable and also on an industrial scale. So what we did was a little bit like cherry picking, so to say. So we had a look at the processes, what works best, what not. So how can we keep the profit in mind, and what should we do to make it scalable at industrial scale? We don't want to have too high investment cost as well. We want a high throughput when you think of all the modules that will arrive within the next years. And our main approach was really to recover the silver. So for the first question, we can say, okay, yes, we solved it. We were able to recover most of the silver from the modules now. So our next problem is the silicon. So today, yes, most industrial recyclers can only produce silicon metal with a purity of around 95%, which is then only suitable in alloys. So this is also the stuff we recycle at the moment. So, but our goal is, however, to reach solar grade quality. That means so 99.99% purity, or so to say 6N silicon. And to achieve this, we are improving our mechanical separation to avoid, yes, contamination of the silicon. We try to develop wet chemical treatment methods. And what we do is all the time we are looking for collaborations with scientific partners to scale up our processes. So when newer cells arrive, so such as maybe TOPCon or heterojunction cell, purification will become a little bit easier, but currently we have the problem with the crystalline silicon cells, so we need to be ready to recycle it now. So the challenge, well, not only for us, it is a challenge for the whole recycling industry for the PV cells to develop a scalable solution that provides an efficient purity of the silicon. So currently, yes, we are working on it. And if you're interested or have any ideas, feel free to reach out. And yes, so second problem is solved a little bit from us, but it is still a challenge to get a good purity of the recovered silicon. So let's come to the plastic fraction. Yeah, what can we do with the recovered plastic, especially the EVA foil as well as the backsheet make up about 10% of each module. So yes, unfortunately, these materials currently have no profitable recycling route. They are often incinerated for energy recovery. This is what we do with this material currently. So yes, with our process, we are able to recover pretty much clean fractions of the plastic. So it would be worse to use it or to reuse it, but the question currently is how to use it. So also here, we are faced with a little bit headwind. So we have some problems with material because we have, yes, often a complex and variable composition, which includes a lot of additives and even fluorinated compounds, which make mechanical recycling a little bit difficult and sometimes hazardous. This is a problem we are faced with. So here as well, a call to you. So we try to explore new approaches and we are actively looking for scientific collaborations to find safe and sustainable solutions for that problem also. So yes, to sum up a little bit what we are able to recover, at the end of the day, we are able to recycle 98% of the materials of the PV modules yet, but up to now with more or less impurities. So what we recover is, of course, the aluminum frames, which go directly back to the aluminum industry. The copper cables are used again in electrical manufacturing. Glass is transformed into high quality flat glass. Silver is also refined now and reused as pure fine silver. Silicon at the moment, as I told you, serves as a feedstock for alloys or maybe for chemicals. But our goal is to achieve the purity to use it for new solar cells. So only plastics are currently thermally utilized. So on average, we can say that, yes, recycled raw materials save around 80% of the energy and CO2 emissions compared to producing virgin materials. And I think this is pretty good. So to do so, we have built our first industrial recycling line, which is shown here. I see, in my opinion, it looks pretty nice. Not like a recycling line. It looks really like a production hall, I think. But yes, we recycle here the PV modules. And our vision does not really stop here. By 2026, we plan to increase our recycling capacity fivefold from 7,000 to 35,000 tons per year. So yes, this expansion will include our first international site in Italy. Fully automated processes will allow us to recycle up to 350,000 modules per year. And I think this can set a new benchmark for sustainable solar waste management. So to sum up, yes, the recycling process is not just an environmental necessity, it is really also an economic opportunity. So now I'm at the end of my talk and thank you for listening.
Thanks, Janett. Very interesting. Yeah, I think the great thing is also that you're expanding already, although at the moment the volumes are not so big actually, and it's great to see that it works and that there's also a business you can live from.